I updated the syllabus. I added the video from last time, so you don't have to subscribe to the YouTube page. You can just go to the class syllabus, and the video that goes with that day will always be posted in that day. Then I updated materials for the next couple weeks. Yeah. Other than quiz 1 is not done yet, but I'll figure out what I want that to be after we get through next week's material. I also added one more reading to the list, and I updated the files in Blackboard to include that reading. So this is a paper I found over the summer and then I had forgotten that I found until last class, and it occurred to me that this would be a good thing to add to your reading list. As you may remember, my position on alpha, did I describe this to you very succinctly last time? It's bullshit, right? And if you're thinking to yourself, okay, great, but how am I going to write in my methods section that because alpha is bullshit, Hoffman, Personal Communication, 2018, I'm going to do this instead, right? You don't have to write that. So you can thank this person, Daniel McNeish. He's written a number of very interesting papers, and this one is no exception. I added this to your list because it has one of the best titles I've ever seen for a manuscript. Thanks, Coefficient Alpha. We'll take it from here. That is the nicest possible way to say alpha is bullshit I could have ever come up with, but this was published just this past year in Psych Methods, so it's like legit. So rather than saying Lisa thinks alpha is bullshit and that's why I'm not reporting it, you can follow the arguments that are in this paper, which we will go over next week. So that has been added to your syllabus. I updated the references on the web page as well as on the syllabus. From this point forward, I will likely not update the printable version of the syllabus as we move things around unless I add readings. That'd be the only point at which I would. This web page will always have the most current version of everything that we're working on. Let's see. Remote desktop, those. Okay. Any questions, thoughts? All right, what do you remember from last time? I will accept words, phrases, gestures. What's this class about? Start with the big one. And feel free to reference words that are in the title of the class in your answer. That may help. Latent trait. Betsy, you were going to say? Late. Very good. And latent means observed or unobserved? Unobserved, that's the big one. So if you needed to measure, say, chronological age, would that require a latent trait? Nope, that would require a birth certificate. That's observed. There's no argument. If you wanted to measure something like functional age, right, or biological age, that's a latent trait because that would require multiple observed measures to do so. So yes, very good answer. Give me some synonyms for latent trait. If it's in SEM, what would it be called? We'll play hangman. One starts with an F. There you go, factor or factor score. Another one starts with a V. Yeah. Latent variable, yes. Latent trait, latent variable. Latent factor, here's another one I can think of, starts with a C. Construct, very good. If you're in an IRT class, this is called what? Theta, yes, I'll give you the little symbol. And if you're in classical test theory, true score, yes. The common denominator, really, behind all of these words, two ideas. Latent, meaning that you can't directly observe it. You have to infer it from more than one observable thing. And continuum. All of these mean that people can be ordered on a continuum. So it's not about classification or classes or types. It's about a continuous measure. And in all of the models we're going to talk about, this continuous measure is assumed to be normally distributed. That's something you rarely can get around in modern software. If you think that you have a trait that is more of a group kind of variable, a have or a have not, that's a different kind of model. And so I'll talk a little bit about that throughout the semester, sort of if this doesn't fit, where would you go next? But those are the two big things, latent traits and unobserved traits, traits that are unobserved. Give me an example of something from your world that would fall under this category. Lucas, what do you want to measure? Institutional confidence. And is it the people in the institution that have the confidence?
More generally, what institutions are people confident, more or less confident in?
Okay, so what types of institutions? Okay, so not their own institution, but just sort of in general? Okay, so do they have to have an idea of a particular kind to answer the questions? You guess not? So if I said think of a school and answer these questions versus think of a church and answer these questions, yeah? Do you think that would matter? Yeah. So this is foreshadowing some of the topics for today, by the way. Good. Who else wants to play? Heather, what do you measure? Oh, that's a thorny one. Executive function, is that one thing? No? How many things is it? It depends on who you ask, right? And it can be more than one thing differently at different points in one's development, right? That's the thorny issue? Yes. How do you measure executive function? Lots of assessments. What do the kids do? Okay, what do the moms do? Oh, so it's self-reported executive function? Okay. Do you think you'd end up with a different picture of EF, as it is called, if you gave them some sort of like cognitive task? Probably. Yeah. So another foreshadowing. Who else? Do you want to play?
Do moral intuitions.
Moral intuitions.
So kind of categorical classifications of moral intuitions. So like kind of like sensitivities to maybe like care or harm, or justice, respect for authority, in group.
Okay. So more specific then. Give me an example item.
Well, typically assess the like moral violations and how offended people are by those.
So they would read some kind of story and then answer some questions about it?
Yeah, the ones with adults right now are mainly just explicit, like how important is this for you when making moral decisions. The one I'm creating for children is that it's like on a scale of very bad to not bad at all. What is this?
Okay. I get you. There's lots of trickiness in there, I suspect. You'll have some interesting work to do. So yeah, good. We have lots and lots of kinds, and a lot of the similar issues are going to be evident in each of those kinds. Let's see, models. Do you remember the kind of models that we're going to do to measure the latent traits? Looking for more vocabulary review here? Remember some? Do I need to play hangman? Does that help? CFA. What does that stand for? Confirmatory factor analysis. Is that the same thing as EFA, exploratory? Hell no. That's next week. That's up. Yes. And what is CFA for? What kind of outcomes? Continuous, normally distributed outcomes. Do any of you actually have any of those? Sometimes people do, but it's pretty rare. How about if you have like correct or incorrect, or yes, no, or yes, no, maybe? Those would be considered categorical outcomes, broadly construed, binary, ordered, or nominal as special cases. What kind of measurement model do you need for those? Yep, IRT, item response theory, or its algebraic twin, IFA, item factor analysis, yes. All of these models are going to have a lot of similarities, but they look different and they're called different things by different people. So I want you to be conversant in all of these things. What if you have other kinds of items? Like what if you have something like response time? Can you fit a measurement model for that? Sure. It doesn't have a special name unless response time is normally distributed, but you could fit, say, a log normal model for response time because it's usually skewed. Likewise, what if you have counts of behaviors? Like you're measuring something like marital discord, and it's like number of mean things you said today, number of times we hit you, number of times you forgot to load the dishwasher like I asked. Counts like that. Can we have a measurement model for that? Sure, absolutely you can. In that case, it would be sort of like a Poisson regression where you'd have a logged version that it would be predicting and a different kind of residual distribution. So we'll talk about those details later, but the point is any kind of outcome that is used to represent a latent trait, there is a model for. You just have to figure out which one it is. And you can mix and match. You can actually have a latent variable that is measured by a binary thing, a normally distributed thing, a 3-category thing, and a 7-category thing. They don't all have to be the same. And you can use that to your advantage when you're constructing new items. That's one of the misconceptions that comes about through classical test theory and adding items up to make a score, that all of the response options have to be the same. They don't. They don't. So I'll show you some examples of that today as well. So, good. Anything that you think I forgot? I think those are the big pictures. No. All right. So then the rest of lecture 1 here is one of my, what I would say, squishier ones. A lot of words and concepts, but I think it's important to at least mention these things because a lot of the problems that you see down the road in terms of misfitting models are foreshadowed when you look at the content of the items and all the ways that the items differ from each other besides the way that you had intended. So I'm picking up on slide 25 of lecture 1. Make sure I'm still recording. Good. All right. So just a couple examples here to try and bring out some of the issues that we're going to be talking about. 2 examples, educational context as well as a more psychological context. So first one, math. Does anybody do math ed in here? Yes, Jacinta, is math a single thing? No. Why do people call it that? Convenience? Sure, right? Am I good at math? Am I bad at math? Is math hard? Well, it depends on the kind of math, right? Yeah, but math is a unitary construct for some folks, but what if you're trying to measure math, and it's math in, say, let's go with, what, 8th grade, 9th grade, algebra and geometry? Let's say that you have questions measuring each of these things, and you add up the number of correct items to use as your indicator of math. Well, first question, if the math test covers algebra and geometry, is this math or is this an algebra test and a geometry test? What do you do if your items happen to measure both? In these sorts of cognitive skills, it's not uncommon that you would have to borrow on more than one type of ability to get to the right answer. Should you double count those items in terms of number correct? Then you're sort of doubly penalizing someone for getting it wrong or right. If one score is sufficient, how accurate is it? You want to have enough items that you get a good sense of someone's ability, but not too many that you either bore them or tire them out. How many is that? I don't really know. What we do know is that when you try to measure more than one thing, you would need at least twice as many items to get to the same level of reliability as if you were measuring one thing. And so that's part of the reason why you end up with these lumpy constructs like math, is because it would require way more items than is humanly possible to get a good measure of every single aspect of math or any other type of multidimensional trait. And do you need all 20? If you have somebody who is doing really, really well on a test, is it necessary to give them all of the really easy items, or could you get away with just giving them all the hard items? Likewise, if you have somebody who's doing very poorly, it can be really discouraging to keep sucking and sucking and sucking, right? You don't want to put someone through that if you don't have to. So how do we get away with using fewer items and making them better? These are the sorts of problems, all of these things, that require moving past classical test theory to address dimensionality, reliability, and to build alternate forms that don't have the same items deliberately. Are there other ways of getting the answer right besides ability? So if you think about your classic word problem, you have to be able to have a reasonable level of reading comprehension to get to the part where you understand how it involves math. So those items can tap a different ability at the same time. When you're adding items up, you're assuming implicitly that they're all equally difficult. There's no weighting that goes on for more or less difficult items. That's potentially problematic. Most of the time in building classical tests, you want to find items that are 50-50 in terms of how many people get them right. Those are supposed to be most sensitive, but not if your goal is to measure a certain level of ability. So test floors and test ceilings, you've heard these phrases before, right? And they're described as bad things, but not necessarily. For instance, you know what distribution of scores I want from you guys at the end of the semester? I want a ceiling and nothing else. It would please me if everybody had 100%. That means that you hopefully have understood the things that I wanted you to understand and that I did my job. A distribution is not necessarily a good thing. Items always have a context, they always have a language, they always have a referent, they always have a stem. And those are the things that can get in the way, particularly when those things are differentially salient to different groups. So to put this in a different context then, measuring something like depression. And I didn't make these up, these are items from actual depression-related measures. So just a sampling of things. Oftentimes when people are talking about behaviors, they go with some sort of frequency, like rarely to almost always. I have lots of energy would be a negative indicator, indicate a lack of depression. I sometimes feel sad. Well, who isn't going to say yes to that, right? I sometimes feel sad. And you may laugh, I see a couple smiles in here. I have seen this before, where people embed a frequency within a frequency response. Rarely do I sometimes feel sad. I feel sad all the time. Or rarely do I sometimes feel sad. I never feel sad. Both of those are rarely. Don't do that. That's not a good idea. I think about ending my life. Do you think that that is the same weight as opposed to I sometimes feel sad? Probably not, right? You don't have to be a clinical psychologist to look at that and go, those fives are not the same. But when you're adding items up, they are. I cry. Rarely, sometimes, always. There's a whole literature in terms of survey methodology about how people interpret what rarely means differently as a function of not only their own personal experience, but the other items. So think about if you were measuring something like health behaviors, and you had a scale of like rarely to almost always, like how often do you brush your teeth? Almost always would be like what, after every meal, maybe 3 times a day? What would rarely be? Someone you don't want to talk to is my guess, right? Versus, I took my 3-year-old to the dentist this morning. How often do you take your child to the dentist? Almost always? What is that? Is that like more than twice a year? It's a different almost always. So in these sorts of items where you're going to get frequencies, it's actually okay within a latent trait context to change what the options are to be more specific to the question. So if you wanted to ask about brushing your teeth, you might say every couple days, once a day, twice a day, after every meal, and have those be your options. Whereas if you wanted to ask how often do you go to the doctor, once a year would be sort of the standard, and you could come up with options around that. When you are adding up items, those sorts of differences cause problems. When you're working from a latent trait context, they do not. And so it's freeing. There's some types of items that naturally don't have a gradation, like how pregnant are you? There's really only one answer to that, right? Not at all, or yes. Trying to make a gradation, unless you start asking about trimesters or something, isn't going to work. So, and you don't have to have a gradation if it doesn't make sense for the item. There's an interesting article that just came out I added to your reference list about positively and negatively worded items. I will tell you this happens all the time that this screws up fit. people respond differently to a lack of affirmation than to an affirmation. So we will see this in an example from the confirmatory factor analysis unit. I have the forgiveness measure, the Heartland Forgiveness Scale, that I helped to analyze as a grad student here. And there is a measure of forgiveness, and then there, on each of the subscales, 3 are reverse coded. So they are unforgiveness. But forgiveness is not the same as a lack of unforgiveness, or vice versa. And in the article, they made, I thought, a good argument as to when those kinds of issues make sense to have positive and negative. It would be for constructs that you honestly think of as bipolar. So can you have happy at one end and maybe sad at the other? If that's the way you think about it, then asking items about how happy are you, blah, 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 and how sad are you, blah, 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 makes sense. If the bottom of your happiness scale is just no happiness whatsoever, then to ask about things about sad is irrelevant. Because a lack of sad is not the same thing as happy, and a lack of happy is not the same thing as sad in that view. So if it's not a bipolar scale, negatively worded items are likely to cause more problems than if it is. And I've seen this like 8,000 million examples that I can think of. So that's something to watch out for when you're using instruments and when you're building instruments, particularly when it gets confounded with the trait you're measuring. And I have a couple examples of that later in the lecture to show you. So you get the idea, right? These are the things we're going to be worried about. So here's those same ideas in terms of more general wording. Dimensionality. How many things is a given item measuring, or a given set of items? Measures of reliability are always assuming unidimensionality. The good news is that latent trait models give you an opportunity to test that assumption. There's always going to be a fight between accuracy and efficiency. You want to measure someone as well as possible, but using just enough items not to bore them or burden them or take up too much time. Reliability. Well, if alpha is bullshit, one of the reasons that a single measure of reliability is bullshit is because items themselves vary in their trait location, their difficulty, or their severity. If you have a whole bunch of, going back to these sorts of depression items here, if you have a whole bunch of depression scale items that are things like, sometimes I don't have energy, and sometimes I feel a little sad, and sometimes I'm a little emotional, that's going to have a really high rate of endorsement and likely more ceiling effects than something like, sometimes I feel like killing myself, sometimes I can't get out of bed in the morning. So you would end up with different distributions, and as a consequence of that, different reliability. If you really need to measure suicidal people well, you want to give items that are targeted to that level of severity. If you really want to measure, what is it, dysphoria, like people who are a little sad, is that it? Can I make this up? No one's going to correct me? Okay, I'm a clinical psychologist today. Little sadness, whatever that trait is called. Then you want these sort of items that most people would endorse to try and get at that. So the juxtaposition of reliability and item selection has to be thought about in terms of what do you want to do with your test. Do you want to measure everybody well? Do you want to measure just the high people well? Do you want to measure the low people well? And a single characterization of reliability is likely to be inaccurate whenever you do have items that vary in difficulty. You are going to get different levels of reliability across the trait. And certain models gloss over that, and certain models focus on that. And bias and generalizability. To what extent are all of the measurement model parameters the same across groups or time? That's always an empirical question that is assumed when you add up items and use the same measure for different groups or different occasions. So, let me take a breath here. Thoughts, questions, comments? Yes, sir. Ryan, right? Okay. Mm-hmm. Mm-hmm. I can, actually, to some extent. So there are two different approaches, I think, when the end goal of the measurement is classification. Even if you believe that, say, there is a spectrum of depression, right? You believe in your heart of hearts it's continuous, but at the end of the day, you need to recommend that this person go to get help or not, or go on meds or not, right? One way is to give them the continuous measure and be like, okay, well, you scored a 15, and that means you need help, and you scored a 14, that means you don't. And then you have to defend that cutoff and hope it replicates across samples and do sensitivity and specificity analyses. But ultimately, the cutoff is squishy, right? It's arbitrary, and it ignores the measurement and classification. Like, how wide of a standard error would you need to reliably say that 14 is different than 15? The other way is to use a measurement model that instead focuses on the classification directly. And that is actually my husband's field of work. They're known as diagnostic classification models. And those models, instead of saying that you have a latent trait, they say that you have a latent group. So you can think of it as a confirmatory version of a latent class model or a latent profile model, where you set up the groups and you say that there's depression or not. And so there may be different kinds of depression, for instance. Can you give me some words? See, that was the word I was looking for a few minutes ago. Why did you let me flounder? No, I was going for like a mild or depression-y thing. The what? Okay, all right. Well, see, when I make shit up, you got to call me on it, all right?
So, like there's different, like, to get classified as mild, like depressive disorder, you have to meet a certain time frame. But there's a certain amount of things that you kind of have from that.
Yeah, the DSM, right?
So you can have someone with 3 traits that are wildly different.
Yes.
Someone who had insomnia, someone who had not eating at all, they sort of correlate these. Like, I don't know how we determine that these are the ones determine it, but the combination can be different.
Right, so there's like maybe 8 issues, and if you have any 3 of them, you need some help. And then which of the 8 you ticked maybe would guide the kind of help?
Yeah, in terms of talking about something that really is more just like for diagnostic purposes.
Okay, so yeah, actually that lends itself directly to that kind of model setup. So what you would do is fit a model where each of those 8 things essentially is a categorical trait. Either you have it or you don't. And the model is set up that way, such that the people who have it would have a higher probability of saying yes or giving a higher score than the people who don't. And you set up the logical combination of all possible combinations. And so, like, if those things are hierarchical, like if, like, suicidality, is that one of them, I'm guessing? So, like, you can think that maybe, all of the milder ones, like, you wouldn't be suicidal unless you already checked all the boxes on the way up. So it would be impossible to have a profile of having, yes, you're suicidal, but no, none of these other things are wrong with you. Like, that would reduce the number of possible combinations that you could observe. But your theoretical model sets that up, and any one item then can measure one or more of those traits. So if it's like, I didn't eat all day because I never got out of bed, well, that's the, the lack of energy trait, and that's the not eating trait, and it can be measuring both. And so then what you get back from the model is the probability that each person has each of those tendencies. And 50-50 means you have no idea based on their pattern of response, and the further it is to 0 or 1, the more certain you can be about that. So it sacrifices the fine-tuning sort of how depressed are you, but it puts the classification in the model directly, so there's no arbitrariness with respect to what score is the cutoff. And it also allows for multidimensional measurement. I used to have a day on those models in this class just to sort of show what they are and show how you can do them in M+. But that usually ends up getting cut out for lack of time. But you can visit his website, and he's given 1 million workshops and classes on it. It's called Diagnostic Classification Models. So it's jonathantemplin.com. He bought his own domain when he bought mine. It was a birthday present, actually. So that's what nerds buy each other for gifts, is domain names. Question?
Yeah, can you compare, let's say you don't actually know whether or not, maybe you want a clear cutoff, but you don't know whether or not that's actually reasonable. Can you compare a model where it's continuous and the models where they're in groups, so you can say, actually, it's one of these things?
Not really. They're designed for different things. The diagnostic models are designed for situations in which you don't have enough items to reliably locate someone on a continuum anyway. Like you can't give that many and still do everything else you need to do. Or in like his case, you have to make a decision, and the decision is part of the model. So, you know, I had said the other day that like confirmatory factor analysis is like linear regression, where the factor is the x. These models are like latent ANOVA instead, where you just set it up like theoretically, I have these groups, and here's how the items map onto the groups. If you're a member of this group, this is how you should respond. If you're a member of that group instead, this is how you should respond. And you can compare model fit to see like how many groups you have and whether or not they're hierarchical in nature. So yes, if that's your goal, that's where I would point you to. It's a whole different set of models, but in order to understand that class, you need this one. So that's a topic that is a lot trickier. So, a long answer to a short question. Did that help? Okay. Other questions on that or otherwise? Things this is making you think about in your own worlds? No? Okay, fair enough. So a little bit about instrument construction. And there's a really nice book that I used to own, but I lent it to somebody and they never brought it back, and I don't remember who it was. So I don't have it anymore, but it's Constructing Measures, from Mark Wilson, 2005. So I'm borrowing a lot of his ideas in text. If you're in the business of needing to make up a new instrument to measure or do something, I would recommend this book. And so he talks about the idea of how you start out the process in terms of defining your construct first. And he has this idea called a construct map. And this idea shows up in the article I was just talking about that I added to your reading list for this section. And I have a couple examples of that from some students that had done work in my class previously when I had asked them to think about this. So yeah, here's the book, by the way, I was talking about, Diagnostic Classification Models. That's one of the textbooks on it. But in this context, when you're trying to measure a continuum, you should be able in your head to think about an ordering of persons and then an ordering of items, and these are logically separate. So in his book, he has this sort of generic schematic where on the left side are respondents who have a high value of this trait, and items over here that are very either severe or difficult, however you want to think about it depending on your context, would be that. Here are some examples that I borrowed from some of my former students, and so this was a woman from speech-language hearing who was talking about speech sounds. So some speech sounds are harder to say than others. So as a parent, I can tell you that M is one of the first ones, m, and then it was ma, eventually, but m was for a long time. N was right up there. My son's first sentence was when I was cleaning out his nose, and he does not like that, and he said, ninny. That's no, mama, in 1-year-old. And so she ordered all of these speech sounds, and then on the respondent side used age as a way to indicate sort of different levels of this trait in terms of having speech fluency and where she thought people would be. Here's another one for second language learners. So you would start sort of at the bottom, like can you speak in one language? Can you read in one language? And then reading in the first and second, speaking in the first, writing in both, and all the way up to being a translator. And these are the types of people who would fall into this each of these categories. So you should be able to conceptualize both sides of it in order to create an instrument. Instrument development then is generally focused on the right side. It's the items. And so once you have that, then it's the process of logically following those continuum to figure out what your model is going to look like. So in his view, the construct comes first. The construct then dictates what items are relevant. So when I say items, I mean outcomes. So these can be experimental trials, these can be self-report items, these can be tasks. Can you think of anything else? But items is sort of generic. Indicator is a synonym for that in a lot of the books. The kind of item that you have then dictates what kind of response space is relevant. So for self-report items, you always get some sort of ordinal scale. For performance items, you might have accuracy, levels of accuracy where partial credit might be possible, as well as maybe response time. The type of response space that you have, whether your outcomes are normally distributed, continuous but not normal, binary, ordinal, or something else, then dictates what kind of measurement model you pick. The world of CFA, IRT, and beyond. And that model, when properly applied, then provides inferences about someone standing on a construct, and the cycle continues. So this bottom spot is where we're focusing this semester. How do you fit the right measurement model given what your response options are, or your response space? And so from my perspective, it's not that only for certain constructs do you have IRT, or only for certain constructs do you have CFA. It's all about the kind of outcomes that you have. And these models tend to be used differentially, with differential frequency in certain fields because of the item format, but that isn't necessarily the case, that field and a model have to go together. So within that process, then, we have a specific context. So you're always trying to measure a certain items don't occur in a vacuum. You usually have to have some kind of reference. So Lucas, that's why I asked you. You said institutional, right? But there's lots of kinds of institutions. And without giving someone an idea as to think of this one in particular, you don't necessarily know what they're telling you about, right? Especially if they have different views on different kinds of institutions. And so that's the kind of thing. The language it's in, the context, the method of administration, those are all the things that you have to think about. And so this is his steps to item design. In theory, you do your lit review. You figure out what's been done before and what's missing. You ask people, focus groups, qualitative research, and so on. You design the instrument, you design the response format, you get people to try it out, they tell you what's wrong with it, and you keep working on it. And so this, in practice, is way harder than it looks. It's really easy to give these steps and to say things like this, cover a single concept with a clear referent, but to do it in practice is kind of hard. So I wanted to give you some examples from things that I've worked with in the past of where these things might go wrong. So never fear, I get to make fun of myself this semester and lots of other people, but I'm just as likely to have been the one in the wrong on some of these as well. So back when I was in grad school, I helped work on a research team that developed the Family Quality of Life Scale from the Beach Center over in Special Ed. And this was one of the original items. I'm not sure if it's still there or not, but I remember having discussions with this because this item turned out not to work as well as some of the other items on the family relations scale. My family members have, how important is it to you? So these were options where it was like only a little important up to like critically important, something like that. My family members have good relationships with extended family members. Okay, that sounds good, but then we get to grandparents, in-laws. Now, some of you may be married or in partnerships. Can you think hypothetically that you might have a different value of relationships with your own parents than with your in-laws? Or that a good relationship might be differentially possible with some family members than others? So if you're in a family like that, how do you answer that question? Well, if it's my parents, I give it a 4, but if my in-laws, then like 2. So people think they're being helpful when they put parentheticals, but that's only true if the parentheticals themselves don't introduce additional irrelevant construct. So that one caused problems. Here's another one that on the face seems fine. So this was in a different subscale. The item was, my family is physically healthy. How important is it to you that your family is physically healthy? What kind of monster is going to say anything but 5? That's an item that no one is going to disagree with, or at least no one is going to admit they disagree with, right? The psychopathy scale is a different instrument. But it's also not actionable. So one of the purposes of the instrument was to identify ways that families' needs weren't being met, and then they could work with their caregivers to make sure that things went better. That item isn't actionable. But you could ask about things that lend themselves to health. How important is it that my family eats a healthy diet? How important is it that my family gets exercise? How important is it that my family sees a doctor when they need to? You can ask about things that would have more variability that aren't necessarily the obvious things that no one's going to say no to. A different set of problems shows up when your response options are not sufficiently exhaustive. Assess the quality of the relationship you have with your children. Emily, what's the relationship quality with your children?
I do not have children.
Oh, so maybe they're latent. You have unobserved children. So let's phrase this in the subjunctive, right? If you were to have children, how good of a relationship would you have with them? It'd be the best, right? That's one way someone without children could answer that question. Someone else might take it literally, well, I don't have children, and therefore I don't have a relationship, so it must be poor, right?
Well, how about adolescent child? Not so good, but like young child.
Yeah, so what if you have, let's say, a 14-year-old and a 3-year-old? Maybe you would answer differently depending on who your referent is. So there's a number of problems with this, but at least in the first case, adding not applicable would solve it. Because missing data can show up for lots of reasons. They could not want to answer your question, they could have carelessly skipped your question, or they could have not known what to say. Prefer not to answer, or not applicable, or even literally, I don't have any kids. Because this was a population that wasn't expected to be a high level of reading, so you might want to be as explicit as possible. But you have to give people the chance to tell you what they can tell you. Missing data is problematic when it occurs for more than one reason. Sir?
Well, when you're going through the coding, you put NA, or they didn't answer, would you just code it 99 anyway, and it's not actually being part of it, because then the NA is actually part of the scale, it's not actually meaningful?
And you know what? I was waiting for that question, and I'm so glad you asked, because up until March, I would have said, yeah, good point. But I found an article this past year that presents a new model that is a hybrid of a nominal model and a partial credit model that allows you to use that NA as usable data. Ooh. He's going to show it to you. Yeah, and because I am such a nice instructor, I gave the TA the hardest possible lecture to share with you because I wanted to challenge him. But yeah, you can do it in M+. It's a model that was just recently developed, but it solves that problem. It finds a way to use NAs and missing, but not put them within the continuum. So it's semi-ordered in the sense that those are nominal responses on the same trait, whereas the rest of it is then within the order. They'd be different ones. Yes. But it was designed for any of those sorts of like other pieces of information that might be relevant, but I don't know what to do with. So I don't have kids missing, not relevant, any of those kinds of things. So do you have data like that by chance? Because that's one of because that's one of the things I was struggling with, is trying to think about which data set I could give him to play with. So if any of you has data like that and you're like, I have no idea what to do with this, do you want to play with it? Come talk to me and we'll make it work. But yeah, I saw that and I was super excited because that is what ends up happening most of the time, is that it becomes missing data. And it isn't missing. If Yeah, you could almost envision what's called a bifactor model, where there'd be another trait of conscientiousness that a certain pattern of giving some kind of response would indicate. Yeah, it's usable information. The question is, what do you do with it? And this is why methods are constantly changing, right? Like, my answer to that question literally would have been different last semester than this semester, because these things are constantly developing. And that means, from my perspective, that my class is never prepped, right, because I'm trying to stay up on what's out there. But from your perspective, it's really cool, because you may be the first person to learn about this model in your field, and you can bring it to your field, and then that makes you stand out even amongst methodologically savvy people for having this. So this is a cool opportunity, right? Yes, ma'am.
So presumably you would need multiple items that have the not applicable option.
Yes. Yeah, it would have to be identified. But there's a lot of instances like this where a question just isn't relevant for whatever reason, and you want to be able to give people the option to tell you that. So, did you have questions in the middle? Just. It's cool, right? Yeah. So if you have any data you want us to play with, we can play with it.
This sometimes happens with demographic questionnaires nowadays, or a lot of people choose not to answer.
Mm-hmm.
So, I just looked at some data where there's 5 demographic questions or questions about sexual orientation, maybe 5 or 6.
Mm-hmm.
And a good number of people choose not to respond.
Choose not to respond as an actual option, as opposed to just I literally didn't write anything down. And I would say you could empirically test whether those are two different things, I think. So yes. And here's my favorite one that I've seen on a survey before. This was for women in prison. To what extent did others make it difficult for you to engage in various activities before your imprisonment? Anyone have a clue what this even means? Because I don't. Others. Meh. Activities. Meh. This is an extreme example, but in trying to make wording general enough, it can become amorphous and useless. So those are not so good items. Here's some not so good scales. I'm going to pick on particular scales. This is the DIRS, the Difficulties in Emotion Regulation scale. This has been the subject of many class projects in my latent trait class, and here are the items from it. It supposedly measures 6 things, and I want to point out that one of the subscales, this is called lack of emotional awareness, has only reverse-coded items. So when you throw this thing in a factor analysis, those items may be correlated not because of what they say, but because of their valence, the fact that they're all worded backwards. And you'll note that there's an R reverse-coded item, those are shown by the underline, sprinkled into each of the other ones except for the first. Can you guess what happens to those items when you factor analyze them? They don't work as well, because most of the other items are worded the other way. In addition to that, there is a confound with respect to referent. So the first several items on this scale say, I do this, I have this, and then after that, it switches to, when I'm upset, ... So you may answer a question about your behavior differently when you're thinking about overall, like, I am clear about my feelings. Yes, I think I'm clear about my feelings, versus when I'm upset, am I clear about my feelings? I will tell you I am not. My default response is cry. Happy? Cry. Mad? Cry. Sad? Cry. Cry is just like strong. And it's like, I don't know what's wrong with me, I need to cry right now. So I would have a different answer as to whether I'm clear about my feelings if I'm upset or not. And when you're starting the scale with one referent in your mind, which is your entire personality, and then it switches to something narrower, you have no way of knowing if the narrow has carryover from the general or vice versa. So I mock this scale not because I think it's unique. I think there's lots of scales that have these sorts of issues. What most likely had happened is that they started with hundreds of items. They did some sort of EFA, and they kept whatever loaded highly, and they were items that were borrowed from different scales to begin with, and so they have these different patterns. But the good news is that this is totally fixable. So do any of you work with this scale? No one in this room? All right, do any of you know people who work with this scale? Get them to fix it. All you have to do is add when I'm upset to some of these items and fix the reverse coding, and you could have a brand new modified DERS that would be cited up the wazoo. You could do it with mass testing or in some other situation where you can get a whole lot of data quick, and this could become an easy fix. Here's an example of someone who did something like that. This is a paper with a former student at UNL in Nebraska who took this class, and he brought me a scale that measures, let's see, SPQBR. I put this on your rating list. Someone's grinning in the back. Do you know this scale? This person? No? Let me get it out. It's on your readings here. I added it just this last week. I don't remember what it's called. That's why I have to look at this. Schizotypal Personality Questionnaire. Brief, revised, and updated. Boom. There's me, because this was his project in this class, and now it's a paper. So I present this to you not just as an example of good items, but as what is logically possible when you get out of here. This is my hope for you, is that you take whatever you're doing and you actually turn it into some kind of product. So this scale had 6-ish dimensions maybe, and so he has the factors here labeled, and each of these factors has subfactors, and some of the items are phrased as you do this, like do you sometimes feel that people are talking about you, versus I often feel that others have it in for me. And this you versus I thing was confounded such that most of the cognitive perceptions, I think it is, the CP factor had you, whereas most of the others had I. Well, that seems like an easy fix, right? So you know what he did? He fixed it. He gave the original test in one sample, did the factor analysis. He fixed it, got a new sample, did the factor analysis. All of that analysis, by the way, is supplement 1 on the paper. The reviewers were not having any of it. But it works better after it's fixed. The psychometrics work better, the factors hold together, the items are more reliable. All of it works better after he fixed it. So I have no idea if people are using this new version of the scale. What I do know is that what he did makes a lot of sense, and it is an empirical question, the extent to which things like changing reverse coding or changing the referent matters. And I would encourage you to pay attention to such things. The same thing as, like you were saying, Justin, you know, you could take that data and you could do an analysis that shows what is the information from this measure if you disregard those not applicables and what is to be gained in terms of reliability or measuring other constructs if you keep them. That's an empirical question. So this is, I like this example for that reason. So thoughts, questions? I don't think so. It went through the original version of the paper because it had so much psychometrics and so many different samples was so long. The feedback was just always, we don't want this much, we don't want this much. And that was more the issue. I don't think anyone was terribly offended. Part of the other issue was that there's this debate about how many factors and subfactors and whether things are higher order or not. And he had done the testing in a way that more clearly answered that question than what other people had done. So let me fast forward to a picture here. Let's scroll. So yeah, this is, some people think it goes this way, and some people think it goes that way. And previous research had not actually done, in the articles he showed me, the proper structural model fit comparisons to answer the question. So I helped him get it right, and now he has this paper. And here's another picture. Let's see if it's in here. Here it is. Those are all the items. So yeah, the highest it could be is 9 things, and then he had compared the subsequent fit of all these other things and was able to say empirically which one was best supported, not just in one sample, but in multiple samples, after fixing the U versus I problems that had messed up some of this. So, yeah.
So
They're each, I don't remember. I want to say they're each on one, but it's possible there may be some cross-loadings in here. I don't quite remember, to be honest. But anyway, this is one of several projects, actually, that have been published from this class. So measurement and variance analyses in particular seem to be posters at like APA or APS. If you do one of those, that seems to be a popular one. So, but anyway, so yeah, he wins. Back to my story here. Response outcomes. I want to rail on this a little bit here because this is another thing that you want to think about differently if you know you're planning a latent trait model versus a what I would call an add shit up model, the classical test theory model. So here's an example of how someone from one of my previous classes had used this property to his benefit in measuring questions about it was religious openness and other kinds of related traits. He had items like this. Do you feel confident in explaining your beliefs? Ranging from not at all to very. How often do you explain your beliefs? Ranging from never up through every day. And note that this set of options is completely realistic given this. It's talking about a conversation and how likely you would do that, as opposed to other kinds of things that might be like, how often do you pray, where multiple times a day might be a reasonable choice for that. And here's another one. How good are you at explaining your beliefs? And here's the options. So if you were to show this to somebody who doesn't understand measurement models, they'd be like, what? You can't do that. You can't add items together with different response formats. They would make you z-score each of them to try and keep the range the same. But no. I'm not going to add them together. You can totally do this. Each item is going to have a set of what are called either levels of difficulty or thresholds that are specific to these options. And you will get empirical evidence as to how separable they are as well. So if you think that struggling a lot and struggling a little and pretty good are kind of the same thing, you can actually test that. There are ways of specifying that in the model. So yeah, this is absolutely not a problem to have as many different responses as it takes to get a good sense of what someone thinks about this question. It's very different than what you are taught in a classical sense. Here's what not to do. This right here, don't ever do this, please. This never, always. Because you know what? If you don't know what 2, 3, and 4 mean, how on earth are they going to? You also have to make sure, if you're using this instrument within a particular language, that the translation works. That's a whole nother thing. There was a student that just graduated, Mohammed, I'm trying to remember his last name, Al-Ghamdi. He was in the REMS program and also in educational policy and leadership. He was working with TIMSS data, it's an international survey. And because he was fluent in Arabic and English, he found several items that the translation was so bad that it actually made them backwards. Like it was, I'm only good at math, and it was like, I'm good at math only, or it was like something to where the placement of the word only like completely messed up the item. And he did the psychometrics that backed it up, that those items absolutely did not work like they were supposed to. And I don't know to what extent that type of knowledge is going to filter its way back up and change the administration of it, but that's something that has to be kept in mind too. So it is never the same thing when translated into different languages. That's where people sort of get away from using words because they think, well, numbers mean the same thing, but that's even worse because then you have no idea what the difference between 2, 3, and 4 is. So more is not always better. So some people like to go to a 7-point scale instead of 5 so that you can get something that's more continuous and potentially normally distributed. But that only makes sense if people can reliably differentiate each of these categories. If they get sort of mushed together, then more doesn't help. And the analyses that we will do will support the extent to which each of these things appears differentiable across items. That's one of the things the analyses will give you in the IRT or IFA framework. So, Mayumi? Mayumi. So tell me about the thing that you were told that Levon can't do. You're, okay. I know that you were told. You were told. It's a slider scale. Mhm. So it's so let me see. Let me get me. Where's my paint? Is this paint? No. So yeah, I'm trying to find paint. I thought I had made a shortcut to it. There it is, Paint 3D. Paint 3D. I know, right? I usually draw with paint because I don't draw on the boards. So you have like a thing that's like this, and here's one end, and what's it called? Okay, I can't draw very well here, so I'm gonna make a D. And this one? And then are they given anything else? And so it's like it starts somewhere in the middle, and you just go and like park it somewhere. Starts all the way to the left. Okay. And then when you put somewhere the click or touch, then it turns into blue, and then you can use your finger or mouse to put however. Okay, so you end up with like a notch somewhere, basically. And what do the distributions of these variables look like? Because this is measured in terms of like distance, like literal pixels or inches or something. Is that right? 0 to 99. Okay. So then this will be like, 70 or something, right? Ish, right. To the best of my paint drawing abilities, that's a 70. There we go. What do the distributions of these variables then look like? So I'm guessing it's not this. Not normally distributed. Do you have any little like notches that have words or anything else on here? No. So I'm guessing it's sort of like something like a mountain climber, something like that. The ones that have notches, that's what they look like. They end up looking like this. So I've seen these sorts of things where they try to help label. So it's the analog of this, and they try to put notches in here for you, but you're allowed to select anywhere on the continuum. Okay, yeah, I've seen ones like that, and they end up looking like this because people sort of relate to the notch, and then they just move off it a little bit, so you end up with these like 5 modal things. But yours is like that. And why can't Levon do this? Is it the sampling? It's not the sampling. It's not the teachers and the kids in the classes and the time and all that, right? Because that is complicated. Okay, I'm gonna. Can you find out more about this argument and come back with it? Sure. Okay, because I want to help you. Yeah, because they have already told me many times, but they, I was like, okay, I already know Levon, and I don't know how different Levon. So, because I was like, whatever they said didn't stick with my brain. Okay, well, I want to help you figure this out. So maybe you can get them to write it down or something, and we can. Exactly, because on the surface of it, I don't see a problem with this kind of data. I can see where it might have a weird distribution, and that's sort of a different problem because then you have to find some kind of probability density function that would match it, the way that like you find normal or you find multinomial or something like that. But that would be the part that I would be concerned about. Do they still have spray can? So I first got, my family got a computer when I was like 8, and I used to sit and do like spray can on here, and just like, that was my favorite. I don't know, Paint 3D. Why do you need to mess with paint? right? Like, what? It wasn't broken, okay? Don't fix it. But yeah, so as a parting note here, so these are the options in terms of how the response formats map onto the models. So when you're in the world of binary, like yes or no, or even if you have multiple choice items where there's only one right answer, that's definitely IRT or IFA. You end up in something called either logistic or a probit model. CFA definitely will not work for those instances. If you have ordinal responses, those go by the name polytomous in the world of IRT. They're also known as a quantitative, and those are best analyzed using a IRT option, such as there's graded response assumes ordinal, partial credit is partially ordered, nominal is also another one if the items are not ordered at all, and whether or not CFA can be used for those kinds of more than two categories but not a whole lot is a huge, huge field of literature as to whether or not that is appropriate. We'll talk about that this semester. Nominal is very tricky to estimate. The model that we just talked about in terms of the not applicable is a combination of partial credit and nominal. And other types of formats can be analyzed with these models, but it's exceedingly painful. So one of the things you want to avoid is like ipsative response formats. Do you know what those are? Where like you have like 5 options and you're like rank order these 5 things from most to worst. Don't do those. Those are bad. Those are really hard to analyze, and they're very bad in terms of giving people the opportunity to tell you about themselves. So briefly as we go, if we'd had like a rank ice cream flavors in the order of preferred to least preferred, and I had vanilla, chocolate, and mint chocolate chip, right? The worst that I could do would be 1, 2, 3. But if you gave me the whole number line, it would be like 1, 5, 8,074,074 because I would eat dog poop before I eat mint chocolate chip ice cream. And if I don't have the chance to express that level of hatred, then you don't really know my trait. Mint and chocolate together is wrong. That is my perspective. Mint is for brushing your teeth, chocolate is dessert, and the two do not go together. What about lavender ice cream? Okay, so lavender is a plant, and ice cream is food, so no. So, but I'm not actually kidding. I hate mint chocolate that much. Like, what is it, Thin Mints? In New York peppermint patties, if I even smell those, I want to hurl. So yeah, if you give me an ipsative response format, I cannot express my hatred the way that I would want to. So just keep that example in the back of your heads when you're thinking of these. So yeah, we got a lot of stuff to work on this semester, but if the items are broken, the model is only going to tell you that they're broken. It can't fix them. So these are the problems that have to be worked out first. And there's absolutely nothing wrong with taking a scale that exists, making it better, providing evidence that it now works better, and putting it out into the world. I'm not one of those people that says you have to give the scale exactly as is or it's not the same. I think that science gives you the opportunity to improve everything, and scales are in that list. So there, drop my marker. Any questions, thoughts before we adjourn? All right, so please find out about the Levon thing. I'm very curious now, and I will see you all next week. Office hours start now.